Compression with DWT and Run-length / Huffman encoding. Wavelet transform followed by Runlength encoding has been used in the last decade in biomedical signal compression. Chin et al., 2006, consider that the Huffman code is less robust against the different statistical characteristics, because it is necessary a prior knowledge of its symbol statistics, but we develop a solution with a static unique code which can be used in different type of ECG. Ballesteros and Gauna, 2009, 2010, developed a compression model for ECG. This work had the following parameters. Family, Dobakis, Simlets and Bior splines, DB6, Sim6, Bior 5.5 levels of decomposition, 3 and 4 levels. Amplitude of the threshold, it is calculated by THP is the threshold of level P, WP is the wavelet coefficients of the detail/course of level pand max. Is the maximum function. Rule of thresholding, hard. Encoding method, Runlength and Huffman. Time, 2, 4, 5 and 10 seconds of the ECG. ECG, records 100, 101, 104, 107, 108 and 200 of the MIT database. Runlength encoding used the consecutive zeros to form the output sequence. The wavelet coefficients of 4 levels of decomposition are the input of the encoding algorithm. The input, D, is composed of detail coefficients, D4, D3, D2, D1, and course coefficients, C4. The value of consecutives 0 is assigned to the output. Huffman tree, detail, left, and course, right. Huffman encoding, 2 code courses for the first and second level of decomposition were computed. Additionally, in the third level, 1 code course was calculated to the course coefficients and other to the detail coefficients. Every code course was composed by 32 codes. Because most of detail coefficients are 0 after the output of the threshold block and the course coefficients are non-zero, 2 different kind of tree were estimated. For detail code course, the average of all detail coefficients of the 6 signals was computed. The average signal is divided in 32 ranges and the Huffman code was estimated. The course code course is calculated according to the distribution. The 32 codes are assigned according to the course amplitude, bigger amplitude has shorter code and smaller amplitude has longer code. Histograms, 101, top, 104, middle, and 107, bottom. The previous picture presents the histograms of the 104 and 107 records, which have different characteristics in time and frequency, but significant similarities in its histograms. According to the detail coefficients, D1, D2, D3, have a histogram with a significant concentration in 1 bar, while the course coefficients, C3, have the energy distributed in many amplitudes. The length of the output stream is theoretically calculated as pi is the probability in the range I, cli is the Huffman code length in the range I. The results of the 101 record with the base Sim6 are presented in. It obtained PRD equals 1.35 and CR equals 9.24 for Runlength encoding and PRD equals 0.98 and CR equals 9.32 for Huffman encoding. The figure 10 presents the result for the base DB6. Runlength encoding obtained PRD equals 1.1 and CR equals 9.11, while Huffman encoding obtained PRD equals 0.91 and CR equals 9.4. Record 101, Case 1. Record 101, Case 2, OO. Although the record 104 has a pathological behavior opposed to the record 101, it is possible to compress the signal with the same code course. According to the figure 11, the quality in the signal with RL encoding is better than Huffman encoding. But, the CR is better in the second method. Record 104. Runlength, PRD equals 0.901 and CR equals 8.78, Huffman, PRD equals 1.08 and CR equals 9.08. The review results for the records 101, 104 and 107 are presented in Table 5. Compression results.